Today, we're going to learn about atoms. So, what are atoms? They are the basic building blocks of ordinary matter. They build molecules that make everything around us. They also have a nucleus that contains both protons and neutrons, protons having a positive charge and neutrons having no charge. They also have electrons that are contained in shells surrounding the nucleus. These electrons have a negative charge. Now we will see a couple of examples that will help us understand this concept a little bit more. Our first example is helium. Helium is represented as He. When you're looking at the elements on the periodic table, you will see a lot of descriptions about the elements. He is the element symbol. Helium is the element name, and the atomic number is the number placed at the top, which also gives you the number of protons and electrons in an element. For helium, the number of protons and electrons would be 2. The atomic weight, or the atomic mass, is represented by the number at the bottom. To get the number of the neutrons for our atom, we look at the atomic mass, and then we round it to the nearest whole number, and subtract it by the number of protons. In this case, you would get the 4, and then you would subtract it by the 2, the number of protons, which would end up giving you 2. So now you have 2 protons, 2 electrons, and 2 neutrons in your element. Based on our knowledge of the element in the periodic table, we can now draw a Bohr diagram. Our element helium has 2 protons, 2 electrons, and 2 neutrons. Now, how will we represent this on the diagram? First, we have to ask ourselves, what should go inside the nucleus? Well, we would have protons and neutrons. So now draw 2 protons and 2 neutrons inside the center. Now, where do the electrons go? Well, electrons go on shells that go around the nucleus or surround the nucleus, but these have rules. So now let's see on the table how many electrons can go on the first shell. Now this table shows you the amount of electrons that can go on each shell. For example, on shell 1, the most electrons you can have is 2. On the second and third, 8. On the fourth and fifth, 18, and 6th, 7th, 32. Now going back to our diagram, since helium only has 2 electrons, we would only need the first shell. So on shell 1, we would draw our 2 electrons, and now we are done with our helium example.
Okay. We're using boron as an example. By looking at the periodic table, we can see that boron's atomic number is 5. So that's the number of protons and electrons it has. We see that it has an atomic mass that is 10.811, so we round it to the nearest whole number, which is 11. We now subtract the atomic number from the atomic mass, and it gives us our neutrons. So let's go ahead and look over here. Our atomic number is 5, so that equals to 5 protons and 5 electrons. 5 protons and 5 electrons. The atomic mass is 10.811, and it's rounded to 11. And in order to find the number of neutrons, we need to subtract the atomic number from the atomic mass, which is 11 minus 5, and it gives us 6 neutrons. When we have the model set up like this, we can identify the valence electrons and the valence shell. So the electrons on the outermost electron shell are called valence electrons. So these electrons on this last shell are called valence electrons. Okay, So now, the shell containing electrons that is furthest from the nucleus is called a valence shell. So the shell that holds the valence electrons is called the valence shell. Now, the number of electron shells is the same as the period number. So, we look here. These rows that go horizontal determines the number of shells the atom has. So, for example, here on period 1, these elements that are on period 1 only have one shell. These elements here that are on period 2 have 2 shells. These elements here that are on the third period, have 3 shells, and so on. Okay, so now let's start with board diagrams. Okay, so we're going to be using carbon as an example. So we start by drawing or writing the element symbol on the center. Carbon's symbol is just a C. Carbon is in the second period, as we could see right here on the periodic table. So it has 2 electron shells. So now we draw the 2 electron shells around the nucleus. 1, 2. On Bohr models, we only add the electrons. So right here we see that our atomic number for carbon is 6, and we had said that the number of protons and electrons in a neutral element or atom they're equal. So if we have 6 protons, then we have 6 electrons as well. So we need to add 6 electrons to the Bohr model. As we see on the table, the first shell can only hold 2 electrons. So we add those into the first shell. 1, 2. Okay, so since we already have 2 electrons already drawn, we need to add the other 4. So we are going to add those 4 to the next shell, and we're going to add them one by one, starting from the right side and going counterclockwise. 1, 2, 3, 4. Now check your work. You should have 6 total electrons for carbon. Only 2 electrons can fit in the first shell, and in the second shell we can hold up to 8 electrons, but in this case we only have 4 since our atomic number is 6. So now to find the number of neutrons, we take the atomic mass, which is 12.011, which we round to 12, and then we subtract the atomic number, which is 6. So that leaves us with 6 neutrons. And that's it for Bohr diagrams. You should know how to draw a Bohr diagram for the first 20 elements.